Right, today I've got a malfunctioning power bank, and I'll show you what I mean. If I press the button here, you can see one blue light. It isn't charging. So if I just grab a USB cable, I tried several just in case you think it's the cable, but this one certainly works. So in fact, oh yeah, I'll charge it up with this power bank. And please don't work now. Yeah, I get nothing at all. Now I can show you this cable works by throwing it into something else. So let's pull this Wi-Fi thing I did the other day over. Do you have an LED on you? I hope so. Yeah, there we go. We've got an LED showing. So the cable's fine, but there's something wrong with the power bank. It won't charge, but it still has one light of battery on it. Now I looked at the manual and there's no obvious way that this might be locked out in some fashion. So we're going to take it apart and see if we can see anything obvious. Now obviously this, as you guys know me, this isn't my forte exactly diagnosing things, but we're going to take it apart and see if there's anything obvious. If nothing else, I can salvage the battery out of here, I would hope. And there's some interesting circuitry in here. If I just turn this on, it's an icy box something or other, but it has a clock inside. So I know that there's charge in it, but it doesn't want to charge. So in fact, I'll just, in case anyone says, why didn't you try turning it on when you charged it? Well, I'm going to do that now. Oh, it doesn't want to turn on now. Oh, there we are. And still not charging, just one light. Now I left it on like this, plugged into the wall for 24 hours and it did nothing. So you can see the light just goes off. No matter how much I wiggle the cable, I've looked for sort of, let's zoom in and see if you can see. There's no obvious damage in there. So frustrating. So let's just try and take it apart, shall we? We'll turn it off. I think these sides are probably glued on. There are no obvious screw holes. So this thing is, here we are, it says on the side, Icy Box 5000. It is a year old, maybe 2, but it's probably only been through about 50 charge cycles. Ooh, that didn't sound good. We're getting somewhere. Oh, it's certainly glued. That is, it feels kind of grim. I'm gonna have to come back to this. Oh, there we go. We're in. So that's what it looks like. Okay. So there are some screws in here, which is good. I best go and get a screwdriver. Now you'll notice it's noisy again, but you know, it's the summer, so you're gonna have to put up with it. I'm having the windows open and my neighbours like to make a lot of noise. I don't begrudge them that, they're kids. So ordinarily for something like this, I'd put a link in the description of where you can get one, but honestly, if it's failed, I'm not all that enthusiastic about it. It came from Reichelt, and they gave it to me as part of that Rune Audio project. This one's not coming out, it's just spinning. Has popped off, or maybe a, there we go. Or a contact that does something. I have no idea. There's a lot going on in there. So that is, it's basically a clock, isn't it? We've got a cell for the time. The time's working fine. That battery's probably all right. In fact, we can test it. Can we see where the battery pins are located? Yeah, 3.2 volts on that cell. And that's our output. Where are our inputs? Well, we might be able to flick this board out. Let's see. Oops, a daisy. Oh, it's pushing up against the buttons over here. Oh! Okay, well that is it out. The battery appears to be normal. Does not appear puffed up. It smells fine. Let's test this battery out. We've got a couple of contacts down here that I can probe onto. .4 volts, except that says minus. My probes are the correct way round. That's odd. So the red wire is over here and the black wire is here. That's very strange. But we are getting 3.2 is certainly a bit low, wasn't it? Let's try that again. And then I might look on the top side of the board. 3.4. No, that's okay. So the battery terminals are just here. 3.48. Now what would be wrong? Now that I've taken this apart further and I can actually see a bit closer into that socket, I can actually see some damage. So that is the issue. Perhaps replacing this socket is the way to go. Right, I've got some connectors. I don't think they're exactly the same footprint, but we're gonna try, because otherwise it's useless without it. That connector is damaged. It needs to come off. What I'm gonna do is I think I'm gonna take the battery off first. So I've bent it back, so we've taken it out of the equation, and I'm just going to desolder it, I think. It's probably safer just to snip the wires, but whatever. That's not what I'm doing. I think I'll pop a little bit of flux on that connector. Just so that wire comes away pretty easily. Where are my tweezers? God, that is a lot of solder. There we go, there's one free. And I think we'll take the other one off too. Actually, no, we won't, because they're not very well marked, but I will get some tape. So I'll tape that on. Just so it's out of the way. And then we'll have a look at this connector. We'll see about taking that off. So I think a generous amount of flux, flood some extra solder on, and then we'll clean it up afterwards. Well, this is a little bit aggressive, but it appears to sort of be working. Well, I say a little bit, it's very aggressive. Now what have I torn off there? Probably not what I wanted to. Hopefully I haven't ripped up all the tracks. Let's clean that up. Well, as you can see, I've really done a bit of a hash job on that, but we're now going to probe it out and see if I've completely ruined it once and for all. I did say this isn't my forte. So we'll put it in continuity mode, and over here this should be ground. Yeah, and that one there should be power, and that should also be ground. It is. Okay, so power and ground are connected. That's all I care about. So let's see if one of these will fit. No, it will not. Well, I think I managed to miss most of that off camera, but I've actually managed to make it fit somehow. So now we're going to attempt to solder the frickin' tiny pins at the back. So I'm going to use a bit of flux here. They've got rather large pads to solder onto, and in fact the other one didn't solder the data lines in, so all I need to do is touch, hopefully, it might be done, it might not. Shall I probe it out? Let's see if we can get 5 volts on this board. Well, it thinks it's charging. It definitely isn't. Something's making a noise though. So let's probe out the voltages here. So let's try, ooh, get that out of the way. Oh, you can't see. So I'm going to try the battery voltage at the bottom. So what's it throwing to the battery? Nothing. It's not detecting it's charging, I don't think. Oh, the battery bank has turned off. So I'll turn it back on again. And it's sitting at 3.7, so it's trying to charge the battery. I think this might be successful. So let's have a little look at our voltages over here. So that one is ground. We've got 5.1 volts. Holy crap. I didn't think that really half-assed attempt at doing this would be successful, but let's get the battery back on. This is probably the dangerous part. I'm not sure we'll be able to get back in the case, but a little bit of flux on there. I know you can't really see. I'm not going to move the battery around now to get it in the right position because I'm slightly frightened. Okay, dangerous bit over. It'd be nice if that bit of solder wasn't lurking around in the thing. And then flip this back over. Spin it around. Here we go. This is lucky. I mean, well, we can test the voltages one more time here. So we should be, what was it, 3.4? So we should be seeing somewhere around that with its resistance on. 3.5 and climbing. Falling, climbing. That is good news. I tell you what, let's find out how much current it's drawing from this power bank. Point, oh, 0.38, 0.4, 0.5 and climbing, so it's requesting a bit more current. Actually, it's not about requesting current because the data lines on this aren't connected. So it looks like this is smart charging the battery there and drawing a little bit more current. Well, who would have thunk it, eh? Not me. So don't attempt to do what I just did and mess around with these. It's fairly high capacity, 5,000 milliamp hour power bank. Could cause a bit of a fire. So although this was successful, I only attempted it because I've seen far stupider people do stuff online than me. But I got it right. I managed to replace that socket in a really horribly ugly way. In fact, I'll give you a close-up look at the socket as it came out. So I tore off a bit of the PCB, great, but managed to get another one back on. That seems to work, and maybe we'll be able to get it back in the case. I don't know. But as it is, it's sort of fixed, I think, which has at least saved a power bank for use in a project later. Whether or not I use it as the power bank it was before, I don't know. We'll see. But yeah, that was dangerous, foolish, and probably not the best way of repairing a power bank. In fact, it's probably best just to dispose of it, but it's fixed. So let loose in the comments about how terrible I am. All right, I'll speak to you all again soon.